The idea that time has a one-way direction, or asymmetry, is known as the arrow of time, sometimes known as time's arrow. It is a general physics unsolved question that was formulated in 1927 by the British astrophysicist Arthur Eddington. According to Eddington, this orientation could be discovered by examining how atoms, molecules, and bodies are organized and could be indicated on a four-dimensional relativistic map of the universe. Welcome back to my channel. Arrow of time is a much discussed subject that captured the imagination of physicists for many years. The inner working of the universe has always captivated the humanity. Despite other great questions that forever may remain unanswered, like, what was before the Big Bang, or in which the universe is expanding to, the arrow of time problem, in my opinion, is on the brink of being unveiled. Please join me today in exploring this captivating idea. We will present some key concepts on why arrow of time seems to point in one direction, toward the future. The reason for this is that minor differences are considerably more likely to occur in big numbers than huge differences. The quick response to the question is, we have no idea, because the apparent existence of an arrow of time is one of contemporary physics' greatest unresolved puzzles. The future is unknown to us, but we can recall our pasts. Effects always follow causes, not the other way around. You can easily accomplish some things, such as break an egg or burn a book, but not the opposite. Most physicists believe that the second principle of thermodynamics, which stipulates that entropy in an isolated system, such as the entire universe as a whole, can never decrease, and this has an impact on the irreversibility of the arrow of time. This has to do with the entropy term from thermodynamics, which is only tangentially relevant to how disorder is understood in everyday life. Entropy will always increase in closed systems, according to thermodynamics. A piece of glass is less disorder than one that is shattered into a million pieces, yet a book that has been burned has more entropy than one that hasn't been burned. Entropy and the arrow of time are connected. But what is entropy? In its most basic form, it can be defined as the variety of microscopic arrangements, in which a variety of components that are joined to make a macroscopic entity may exist. How many items are included in the set, and how many different ways they can be distributed, determine the number of possible configurations. Whatever the factors are, this law is constant. They could be anything, from playing cards to atoms. The idea behind it is the same. It has to do with how much order, or chaos, is in a system. Any random distribution of particles and energy is based on a simple statistical truth that holds for everything, and it has enormous implications for all physical systems. Particles and energy will disperse during every change that occurs inside a closed system, in order to get at the configuration that has the least amount of distribution disparities, and is therefore the most likely. As a result, although extreme configurations are extremely unusual in practice, they can exist in theory. The quantity of items to be distributed, and the total number of conceivable combinations of those items, determine how infrequently it occurs. The presence of the arrow of time and its idea have long baffled scientists and philosophers. One of the most aggravating aspects of this is that time is reversible. According to our laws of physics, nothing in the equations themselves says that time can only move in one direction. The idea that time is an illusion offers one answer to this problem, that it can go seamlessly back and forth between the past and the future. Time is merely an illusion created by awareness. Putting a date on each feeling allows our brains to organize the chaotic tangle of sensory inputs that are continuously bombarding us and keeps us alive and functional. There is no need for the cosmos to organize itself in this way. Can time just exist for our convenience? Can time as an emergent concept? On the other hand, the entire universe appears to have a tangible past that existed long before we developed awareness and began observing it. Another conclusion is that time does really exist, and that we are compelled to go forward. In this manner, causality is maintained. In this manner, causality is maintained. The logical links that support the material cosmos would disintegrate if we permitted backward time travel, because consequences may then occur before causes. Paradoxes arise if time could move in any direction. Things might budge before being struck. People might be resurrected. You could murder your own grandparents, which would make it impossible for you to go back in time and carry out the deed in the first place. However, since this chronology protection conjecture defies the laws of physics, there is no way for us to test it. So maybe there is a reason behind the arrow of time. One fascinating hypothesis is how physics cares about time, which is rather complicated. For example, think of dropping a coffee mug to the floor and having it break into a million pieces, with coffee all over the place. There is nothing in the world that can stop you from methodically locating every single coffee mug component and coffee molecule, and reassembling everything. Simply put, it would involve a tremendous amount of work. A huge amount of energy needed to be put to work, and even if the rules of physics do not prohibit you from getting your coffee back, doing so would be very tough and complicated. The same holds true for any other macroscopic system. There may be a relationship between the fact that time always advances and that entropy always rises. After all, it is the only significant location in physics where a physical arrow of time can be observed. Although there is a connection, physicists have not been able to elucidate how it operates, or glean any additional information. Does this statistical thermodynamic process actually affect how time moves, and if so, how does that affect our view of time as a whole? Unfortunately, we only have a macroscopic understanding of the world in which we exist. When trillions of atoms and molecules are randomly scattered in space, and are exchanging energy, they act in accordance with quantum mechanics, which nobody truly understands. As a result, the course of events is set in stone. The overall disorder and entropy both rise with each transition. Greater disorder in the universe as a whole is paid for by the order that we as intelligent creatures can generate locally, and payment typically occurs through the discharge of heat into space. Time is irreversible due to this statistical law, which states that transformations involving macro-scale objects inevitably result in an increase in entropy. Even if no physical law would be broken, if this occurred, it does not happen in nature for a broken glass to be put back together into an unbroken glass. Time travel is improbable, I would say impossible, for the same statistical reason. Rewinding time would imply returning the cosmos, or a portion of it, to a macroscopic state with less entropy. Imagine, for instance, being able to go back in time, to the instant the coffee mug was still on the table, just before falling. You must reduce the universe's overall entropy to achieve this. The rule of big numbers that governs us, and the world around us, appears to make it impossible to go back and change the tape of the events in any way. We cannot reverse the arrow of time because we cannot reduce the entire amount of entropy. I would say that we observe that the time has an arrow, the arrow of time, simply because we are in the vicinity of a singularity, the Big Bang. From human perspective, 14 billion years since the Big Bang is a very, very long time, but at universe's scale, it is a blip. The far future of the universe seems to resemble something close to a de Sitter space, a special kind of space that expands forever, and without matter and radiation in it, such time scales that are so vast, monstrously vast, it is so far away into the future, that we humans cannot comprehend. Speaking in absolute terms like, always, or forever, when we contemplate exponential time scales, I like to say that even diamonds are not forever. There are no such things as forever, or endless, or infinity, in mathematics may be, but not in the physical world. This being said, if protons do not decay, meaning that if anyone or anything that could be theoretically alive then, by looking back in time to our present, it will look for them that our time is still part of the Big Bang, in fact the whole stellar era, which will still take another 100 trillion years from now, will be considered just a blink of an eye, part of the Big Bang itself. In that universe, so far into the future, the de Sitter universe, time will lose any meaning. This is far beyond stellar era, far beyond black hole era and even the iron stars era. It is beyond eternity itself for all the practical purposes, when entropy would have already closed the chapter on things. But even beyond all this time scales, beyond entropy itself, if we can ever say that without being accused of heresy, somewhere in that dark, cold, thermalized, and infinite universe, a quantum fluctuation will still have a non-zero chance to happen, the universe have already reached by then the Poincare recurrence time, when arrow of time will have meaning again, a new universe is born. Well, this is it for today. One can argue that as long as entropy will still have, statistical speaking, ways to evolve, an arrow of time will always emerge. Please subscribe if you think it was interesting. Thank you for watching.